Welcome to The Explainer. Today, we're diving into something I think is pretty awesome. We're going to take a fully functional, voice-controlled robot and basically do a digital teardown, piece by piece, so you can see exactly what makes it tick.
You ever see a cool project like this and think, man, I'd love to build that, but it seems way too complicated? Well, that's what we're here to fix. We're going to break down this entire voice-controlled robot into a super simple recipe. By the end of this, you'll get the whole picture.
So, here's our game plan. We'll start with the foundation, the robot's skeleton and body. Then, we'll jump into how it gets its juice, with the power and heartbeat. After that, we'll look at the muscles and movement. And finally, we'll get to the really good stuff, the dual-core brain that runs the whole show.
All right, let's get into it. Section 1, the skeleton and body. You know, before you can do any of the cool electronic wizardry, you need something to put it all on. You need a physical frame, and it's got to be solid.
Okay, so the body is really made of two key parts. First, you've got this beefy four-wheel drive chassis. This is its ticket to get around, giving it the grip and power to move. Then, there's the really interactive part, a custom 3D printed robotic arm. This is what lets it actually do things. Pick stuff up, move it, you get the idea.
Now, putting it all together, well, it's a bit more involved than just snapping some plastic bricks together. You're going to need tools like a soldering iron for those permanent, reliable connections and a glue gun for everything else. And you see all these wires in the breadboard? That breadboard is your best friend when you're starting out. It lets you test all your electronic connections without making anything permanent. It's an absolute lifesaver for figuring things out. Okay, we have a body. Now, it's time to give it a pulse. Let's talk about Section 2. The power and heartbeat. This is all about the electrical circulatory system that brings our machine to life.
So the flow of energy is pretty clever. It all starts with these two workhorse 18650 lithium-ion batteries. You see these in everything from laptops to vapes. Then, for easy top-ups, there's a modern Type-C charging module. Super convenient. But this last part is absolutely crucial. You can't just hook those batteries straight up to the brain. You'd fry it. That's where this step-down converter comes in. It's like a translator, taking the raw, high voltage from the batteries and converting it into a safe, stable voltage the delicate electronics can actually use.
And you know, after all that smart power management, it all comes down to one little thing, the good old-fashioned power switch. It might look simple, but it's the gatekeeper. It's the final say on whether our creation wakes up or goes to sleep. Never underestimate the power of a simple switch. All right, we have a body and it has a heartbeat. Now it's time for some action. Let's move on to Section 3, muscles and movement. This is how the robot actually gets things done.
Now this robot has two totally different kinds of muscles. For driving the wheels, it uses these four powerful DC motors. Think of these as the robot's leg muscles. They're all about raw, continuous power to get from A to B. But for the arm, you need finesse. That's where the 6 servo motors come in. These are more like the muscles in your fingers. They're built for incredibly precise controlled movements to exact angles. Power for locomotion, precision for manipulation.
So here's the challenge. The robot's brain is smart, but it's not strong. It speaks in whispers of low-power signals. The motors, on the other hand, need a high-power shout to get moving. Connect them directly? Puff of smoke. That's where this motor driver module comes in. It's basically a bodyguard and a translator for the brain. It listens to the brain's quiet instructions and then shouts them at the motors with all the power they need. It's the essential bridge between thought and action. And now we have arrived at the grand finale, the part that makes this a robot and not just a remote-controlled car. Welcome to Section 4, the dual-core brain. This is the command center where the real magic happens.
The brain of this entire operation is one of my favorite little chips, the ESP32. It's a microcontroller, which basically means it's a whole tiny computer on a single chip. And what makes the ESP32 so perfect for this project is that it has Wi-Fi and Bluetooth baked right in. That's the key. That's how we can talk to it with our voice from a phone. No extra hardware needed.
But here is where this design gets really, really smart. It doesn't just have one brain, it has two. It uses what's called a master-slave setup. Think of it like a CEO and a manager. The master ESP32 is the CEO. Its only job is to listen for your voice commands over Bluetooth and make the big decisions. Then it delegates. It sends the orders to the slave ESP32, which acts as the manager, handling all the nitty-gritty details of actually telling each motor what to do. Splitting the workload like this makes the whole system way more responsive and efficient.
And just like that, there you have it. You take a chassis and a 3D printed arm.
You give it power with some batteries and regulators, you add some DC and servo motors for muscle, and you control it all with two little computer chips working together. When all those parts are connected and working in harmony, it stops being a pile of electronics and becomes something else entirely, a machine you can actually command with your voice.
So, we've laid out all the ingredients for you. We've shown you the complete recipe for a voice-controlled robot. The only thing left to ask is, what are you going to build? What kind of amazing idea would you bring to life with these parts? I, for one, would love to see it.